So, whoa, if you remember what we did last time, we are now back up to here. So this is about determining formulas of ionic compounds. So this part of the flow chart is ionic compounds. So we determined a compound is ionic. How do we come up with the formula? And so you can see the boxes here. The next set of slides will explain the boxes. The four types of ions, are representative metal ions, transitional and post-transitional, monatomic nonmetal ions, and polyatomic ions. So we'll go through all of these and how to figure out how to put them all together. All right, so this is in flowchart form. So the representative metal ions, and remember we're using the new numbering system for the periodic table, so the column numbers are just numbered 1 through 18. So the representative metal ions are characterized by forming an ion, only one ion. So they're group 1, 2, 13, and then zinc, cadmium, and silver. For these, the charge will be the group number which is in the ones place, and the name will be the element name. So for example, barium ion, barium is in group 2, so the charge is +2. Aluminum ion, right? Aluminum is in group 13, so if you look at the number 13, 3 is in the ones place, so the charge is +3. Okay, zinc ion, zinc is in group 12, so the 2 is in the ones place, so it's a +2. All right, so you can give these a go. Feel free to hit pause. All right, now that you've come back, I'll just click on the answers. Okay, calcium is in group 2, so it's a +2. Cadmium, group 12, it's a +2. Potassium is in group 1, it's a +1. And gallium is in group 13, like aluminum, so it's a +3. All right, so moving along, that takes care of the representative metal ions. The rest of the metals, okay, the transition metal ions, which are and the post-transitional metals, these are characterized by forming more than one ion. So this is a little complicated. You can't just go, oh, it's iron, this will be its charge. You basically have to be told. So that makes it easy, and the nomenclature is that the charge will be in Roman numerals. So for example, iron with a Roman numeral 2 is iron with a +2. Tin with a Roman numeral 4 is called tin 4. Chromium 2 is tin 2 is a +2. Chromium 6 is a +6. All right? So the nonmetal ions, okay, so you know where the nonmetals are on the periodic table. Remember that nonmetals form negatively charged ions. All right, so for these, it's the group number in the ones place -8. So it's a little bit of math. The name of nonmetal ions is the stem name with an "ide," that's I-D-E, like dog, suffix. So oxide is from oxygen. Oxygen is in group 16, so its charge is -2. Phosphide from phosphorus, it's in group 15, so 5 minus 8 is -3. Iodide, okay, after Io was sick, he died, ha ha ha. All right, so that's in group 17, so 7 minus 8 is -1. Okay, once again, give these a go on your own, hit pause, see if you can come up with them, or you can do the PowerPoint on your own without the narration. Give you a moment to hit pause and come back. And then once again, doing the same thing. Sulfide is from sulfur. It's in group 16, so it's -2. Nitride from nitrogen, right? So 5 minus 8, excuse me. Chloride from chlorine. It's in group 17, -1, and so on. I think you can see none of the steps are hard. It's just that there's a lot of steps. That's why it's imperative that you go step by step. Now, the polyatomic ions are very difficult. I would say there are some tricks to it. This is a list, and you just really need to know these. There are some tricks to it, but it's really hard for me to go through the tricks. I can kind of do it quickly. Whoops. Just go in here. If you look at the chlorine series here, chlorate, if you look at the one that ends in 8, you'll note that the one, I don't know what's going on with this, the one that ends in "ite" is 1 oxygen less. See that? All right, so chlorate is 3, chlorite is 2. It works the same for iodate and iodite. Sulfate is SO4, sulfite is SO3. So if you memorize the one that ends in 8, that will work. Sometimes there's more. The prefix hypo means below or under. So hypochlorite is below chlorite. So see how chlorite is ClO2, hypochlorite is ClO. The charge stays the same. Perchlorate, so per is an abbreviation for hyper. So hypo means below, hyper means above. So if you if you know chlorate, for example, the chlorine series, right? Chlorate is ClO3. You have to memorize that. But if you know chlorate, chlorite is going to be 1 oxygen less. Hypochlorite will be 1 less again, and so on. On top of it, because elements in the same column follow the same properties, if you know the chlorine series, the iodine series follows the same pattern. On the exam, the first exam where you have nomenclature, I will attach this, but I will not, or I'll give it to you. I will not give it to you on the exam 4 or on the final. All right, so you definitely have to learn these, and in Chem 200, they're going to expect that you know them. So I would say start early. There's a copy of this on the website as well, on the Canvas site. When you're going through nomenclature homework, I would just have a copy of this out on my desk, because you look it up a bunch of times, you'll have it. All right, so once we know the ions, how do we put them together? So for nomenclature of ionic compounds, the idea is you need to get the symbols from the name, then you get the charges, which I've just shown you. Then we have to put them together. And the bottom line is a compound has no net charge. So if there's no net charge, that means the ions which are charged, the charges have to cancel. So what we do is we multiply the ion by a magic number to bring the charges to the least common multiple. That magic number, the multiplier, becomes the subscript. So for example, if I'm going to make a compound from iron 3 and sulfate, a polyatomic ion, okay, I look at the charges. Charges are 3 and 2. The least common multiple of 3 and 2 is 6. That means I need 6 positives and 6 negatives. To get to 6 positives, I need 2 of the ion with the +3 charge. To get to 6 negatives, I need 3 of the ion with the -2. These two numbers, you can see the 2 here is the 2 for the iron. Those are your subscripts. The 3 here is that 3 right down there. If you have more than one of a polyatomic ion, you have to put it in parentheses. If you recall, when we were actually meeting in the same room, we talked about MgOH2, and I asked why the OH, why it's not MgO2H2. It's because that's a polyatomic ion. Right? So I'm going to walk you through a couple of these. We'll see if we can do these together, and then I'll give you some to try. Right, so we're at the stage we're going to write formulas. So potassium sulfides, we'll do each one separately. So the mantra, get the symbols, get the charges, put them together. So for potassium sulfide, the symbols are K and S. Then to get the charges, potassium is a group 1 metal, so it's a +1. Sulfur is a non-metal in group 16, so its charge is -2. Feel free to review the slides because each step, right? So the first thing we do, what are the symbols? Okay, potassium, it's a metal. Where is it? It's a group 1 metal, so we can get the charge. Then to put them together, we make the charges cancel. We need 2 potassiums and 1 sulfur, right? So the formula will be K2S. Always write the positive ion first, but also the order of the name will be the order of the symbols. So, okay, for calcium phosphate, next example. So step 1, get the symbols. Calcium is Ca, phosphate. If you can't find it on the periodic table, probably a polyatomic ion. That ends in ate or ite, definitely a polyatomic ion. All right, so then calcium, we have phosphate, that's a polyatomic ion, so we look it up. Right now you look it up on the sheet until you get it down. After that, you look it up between your ears. All right, so we have to get the charges here to 6, so we need 3 of the calciums, 2 of the phosphates. Again, how do we know 6? Because we have a 2 and a 3. The least common multiple is 6. All right, so lead 4 chloride. So lead, if you look at the periodic table, Pb, well, it's in that part of the table that we can't predict the charge. But the name says it's 4, so it's lead 4. okay, with a +4. And calcium is a nonmetal in group 17, Cl-. Putting them together to make the charges cancel, PbCl4. I think you can see it. And then ammonium nitrate, okay, both of these are polyatomic ions. In this case, it's 1 to 1, so we just write it like that, NH4NO3. We do not write N2H4O3. We're writing the ions as separate entities. That helps us, know what kind of a compound it is. All right, so do these, hit pause, give yourself some time, go through them. I'm going to count to 10, just in my mind, but you can go ahead and hit pause, and I'm going to go to the answers. Okay, so just another set of examples. So sodium oxide, Na, right, for sodium, O for oxygen, group 1 metal, Na+, okay, so +1. Oxygen's a non-metal in group 16, so it's a -2. Okay, so putting them together, it'll be Na2O. Barium hydroxide, barium is Ba, it's a group 2 metal, so it's a +2. Hydroxide is a polyatomic ion, so it's a -1. All right, putting them together, we have to get the charges to be 2 and -2. We need 2 of the hydroxides, so the hydroxide goes in parentheses. Okay. The next one was cobalt-2 iodide. So cobalt is Co, it's a transition metal. How do I know the charge? It says so right there, +2. Iodine is a nonmetal. It's in group 17, it's a -1, so to get them to cancel, COI2. Okay. And then ammonium sulfate, again, both polyatomic ions. So ammonium is NH4 with a +1, sulfate's a -2. That means we need 2 of the ammoniums, so the ammonium goes in parentheses. So I think you can see step by step, right? So I think this is a good stopping point, so we'll stop here. Let me stop this.